Doorkeeper, a sign that lights up to leave a message when someone approaches your door. It will have a small screen, motion sensor, and user input to select different preset messages, like do not enter, enter quietly, and free to enter. So, we will start by testing out and working with components on a breadboard to avoid soldering. For this project, we will use a Nano Board that is compatible with Arduino software. After connecting the Nano Board to the breadboard with jumper wires, we can begin testing out different electronic components. The LCD display being used already comes with a serial interface adapter to simplify wiring and soldering, leaving ground, VCC, SDA, and SCL. On the Nano Board, SCL is A5 and SDA is A4. There is also a potentiometer on the serial interface adapter to adjust the LCD display's contrast. To use the LCD display, there is a liquid crystal library with multiple functions already provided. A link to the library is in the description below for reference. After confirming the LCD display works, we will test the PIR or passive infrared sensor to detect movement when someone approaches a doorkeeper. This sensor requires ground, digital output, and VCC. The two onboard potentiometers can be adjusted to change sensitivity and time delay. To test out the PIR sensor, we want one of the nanoboard's onboard LED to light up when movement is sensed and turn off when nothing is sensed. Digital read is a function that reads the digital output of the sensor, which will return high or low. It is a bit hard to see the light being turned on, as there are two right next to each other, where one is always on. But you can see the light getting noticeably brighter when motion is detected. With the sensor working, we will test the slide potentiometer. This will determine which of the preset messages is selected, depending on the position of the slider. This particular potentiometer is a linear 10K, meaning that the resistance changes from 0 to 10K ohms and increases linearly. The potentiometer needs ground, analog output, and VCC. After the potentiometer is properly set up, we can have it continuously use analog read to read the analog output and print the sensor value. Unfortunately, if you look close enough, the values do not change linearly, which is most likely due to manufacturing inconsistencies. We will keep track of the values when the slider is at the 1/3 and 2/3 position so that the three preset messages will be evenly spaced out on the potentiometer. This appears to be around 200 and 850 for the analog values. After testing out all the components, we can start to put them together. We have the LCD display, PIR sensor, and slide potentiometer. With the electronics setup, we have the Nano Board continuously check the potentiometer values and change the message on the LCD display, depending on the position of the slider. After doing so, the PIR sensor reading will also be checked. If the reading is high, the LCD display's backlight will be turned on using the set backlight function. If the reading is low, then the LCD's backlight will be turned off. The pins on the slide potentiometer did not fit tightly into the jumper wires, which can be quickly rectified with some hot glue in the next iteration. Despite this issue, the sensor does detect motion and lights up the LCD as a result. And by moving the slider on the potentiometer, the different preset messages can be shown. It is important to note that this PIR sensor has a time delay that ranges from 5 seconds to 5 minutes, so there will always be a wait time before the sensor is active again and can turn on the LCD backlight. After making sure the Doorkeeper is functioning properly, the components can be soldered onto a Protoboard. Some of the jumper wires used will be cut and stripped for a more neat wiring, and hot glue will be used to secure loose connections. Soldered components include the Nano Board, its ground and 5V output wires to power the sensor, display, and potentiometer, the LCD display, the PIR sensor with its shortened jumper wires, and the slide potentiometer, also with its shortened jumper wires. With the soldering finished, we will add a small piece of packaging foam to protect the soldering job. Then we can move on to designing and catting the outer casing, starting with the bottom housing. This will hold the soldered protoboard along with the power bank, which will power the Nano Board. We will add some more packaging foam to minimize the empty space inside the housing, and some scrap pieces for secure positioning. After that, we can CAD and print the top housing. This piece has slots for the LCD, sensor, and potentiometer. With the casing completed, we can screw the top and bottom pieces together. The final part to create is the slider cap. This secures onto the slider in the potentiometer. Finally, we attach the power bank and the cable. And here it is, the finished product, the Doorkeeper. Thank you.